We have here, this is a Fourier series equation. So they want us out of these to form equations, and then find the Fourier series. Now, before we work on this equation, we must get the gradient of this line, and this is a function that repeats itself after period 2 pi. Now, we have the coordinates at the point of origin. We have that is the coordinate, and then at this point we have pi, that's the value of y, and then we have 2 pi, that's the value of x. Therefore, using the 2 points, we can be able to get the gradient of that line. We know that gradient is given by change in y over change in x. Therefore, the gradient equals to 2 pi equals to, it will be, the value of y here is pi, the value of x there is 2 pi. So gradient is change in y over change in x, so it will be pi minus 0, pi minus 0 over 2 pi minus 0, which equals to pi over 2 pi, here 1, which equals to a half. So what we are saying that the gradient of this line is a half. Y equals to a half. So once we are able to get the gradient of this line, which is y equals to a half, we can now form the equations. We are saying that f of x equals to a half x in the given range. X is greater than 0, but x is less than 2 pi. And then we have f of x plus 2 pi equals to f of x. So we are now going to get the Fourier series of this equation. Now, the period here is 2 pi. Now, Fourier series is given by, let me write up there. Fourier series, which is f of x, is given by a naught over 2 plus summation from n equals to 1 to positive infinity an So that is the Fourier series is given by f of x equals to a naught over 2 plus the summation beginning from n equals to 1 up to positive infinity a subscript n cos nx plus b subscript n sine nx. So we are now required to get the values of the constant. Once we get the values of the constant, we come and replace them in that formula, then we will have gotten the Fourier series. Now, a naught is given by pi over 2, 1 over pi, the integral. Now we are integrating from 0 to 2 pi. So we shall have from 0 to 2 pi. Then our f of x is a half x dx. A half x dx. So this equals to, we can take out 2, we can take out a half because it's a constant. So we have 1 over 2 pi, the integral 2 pi x dx. Now we integrate x, so this equals to 1 over 2 pi. So when you integrate x, you get x squared all over 2. Then we have 2 pi, and then we have 0. You can take out 2 again, a half, which will be 1 over 4 pi we are taking out 1 all over 2 times 1 all over 2, so we have 1 over 4 pi into x squared, then we have 2 pi, then 0. So we can now substitute equals to 1 all over 4 pi into, where there is x, we substitute with the 2 pi, so we have 2 pi squared, then minus 0, minus 0 squared. So this equals to 1 all over 4 pi. When you square 2 pi, we have 4 pi squared, then that is 0. Okay, so 1 pi will come with this pi, and therefore we have 4 pi over 4 here 1, 4 here 1, which equals to pi. So what we are saying is that a naught equals to pi. So we have a naught. Move on now to get a subscript n. We have this. An is given by 1 all over pi. The integral, we are integrating from 0 to 2 pi. So 0 to 2 pi. Our f of x is a half x cos nx dx. So we take out a half because it's a constant. So this equals to 1 all over 2 pi. We are integrating from 0 to 2 pi. Then we have x cos nx, then dx. So here we integrate this 1 pi parts. We shall assign x will be our u, and then cos nx will be our dv. Now, when you are integrating with the integration by parts, when the log term is present, you take it as u. Now, in this case, we don't have the log term. Then the second is that when the power of x is present is taken as u. You can see we have the power of x. That's why we are taking this one as u. Otherwise, when you take this one as u, what remains becomes dv. And when the log term is not present and the power of x is not present, then you take the exponential function as u. But in this case now, the power of x is present, so it's taken as u, and then the remaining becomes our dv. Now, so we have u equals to x. So we differentiate this equation, we differentiate with respect to x, so we get du dx equals to 1. Therefore, du equals to dx, we multiply both sides by dx, so we are saying du equals to dx. And then here we are saying that dv equals to cos nx. So to get the value of v, then we integrate both sides of this equation. So we integrate dv equals to the integral of cos nx, then dx. Now, when you integrate dv, you get v, and then when you integrate cos nx dx, we shall be able to get sin nx all over n. Now, once we have all this, then integration by part formula is given by uv minus integral of v du. This is the formula that we want to apply to solve this. Now, we shall come back here and say that this is 1 over 2 pi into, we now apply the integration by parts, which is this one, uv minus the integral of v du. Now substitute in this formula. So this equals to 1 over 2 pi into, our u here is x, our u is x, our v is sin nx all over n. Then we are integrating from 0 to 2 pi, then minus the integral of our v is sin sin nx over n, then du equals to dx, so this will be dx, like that, from 0 to 2 pi, from 0 to 2 pi. Okay, so let me wrap here. So we have this equals to 1 over 2 pi. So this is x over n sine nx 2 pi 0 minus. So here we take 1 over n outside because it's a constant, so it will be minus 1 over n, the integral 2 pi, we have sine nx dx, like that, like that. So at this point, we now need to integrate sine nx. So this equals to 1 over 2 pi into, I can have this 1 over n. We have x sine nx, then minus. So this is 1 over n. Now when you integrate sine nx, you get negative cos nx over n, like that. Therefore, we have this sign and this one, because as negative will return positive here, and then we take outside 1 over n, so that we have 1 over 2 pi into 1 over n into x sine nx. Those are the conditions. Then this and this will be plus. We take out 1 over n, so it will be 1 over n squared into cos nx, like that. So once we have done this, we now substitute in. Now this, when you substitute, when n, so here we have this equals 1 over 2 pi into 1 over n into, so where there is x we substitute with, so we shall have 2 pi here sine 2 pi n, then minus, substitute it to be 0 sine 0, like that, then plus 1 over n squared into cos 2 pi n minus cos 0, minus cos 0. Now we shall use our calculator. So here we need to confirm, because we shall, of course, sine 0, this will be 0, this is 0, and then we need to confirm for the odd and even numbers, when n is odd and when n is even, to find out whether this series is there or not. So to test for odd, we normally use when n is 1. So when n is 1, meaning here we have sine 2 pi. Sine 2 pi is the same as sine 360. So we confirm sine 360. So sine 360 is 0. So when n is odd, then we test when n is even, we use n2. When n is 2, so 2 times 2, 4 times pi is like we are getting sine 720. So you also confirm sine 720. So sine 720 is also 0. So it means that both at even and odd numbers, this does not exist. The series is not there. So we are done with this. So we are remaining with this one. So we can rewrite here as 1 over 2 pi into, now here we have 1 over n squared into, now we have cos 2 pi n minus cos 0. Cos 0 is 1, so it's like we have cos cos 2 pi n minus 1. Now we also want to test for even and odd numbers. So we test here when n is 1 and when n is 2. So when n is 1, it means that this is cos 2 pi. Cos 2 pi is the same as cos 360. So cos 360 is 1 when n is 1. So meaning we shall have 1 minus 1, meaning it will be 0. So for odd numbers, this also does not exist. So we test when n is 2. So 2 times 2 is 4 pi. 4 pi is like we are getting cos 720. We also confirm cos 720 is 1. So cos 720 is 1. So 1 minus 1. So meaning that this one is 0 again. Therefore, we are saying that our an equals to 0. Our an is equals to 0. So our an equals to 0. Now wrap this. So we have gotten an. So we remain with Pn. Pn is given by 1 all over pi. We are integrating from 0 to 2 pi. So we have our f of x is 0 to 2 pi. Our f of x is a half x sine nx dx, like that. Therefore, we take out a half. So this equals to 1 all over 2 pi, integrating from 0 to 2 pi. Then we have x sine nx dx. We integrate by parts here. We do the assigning. This will be our u. This one will be our dv. So u equals to x. We differentiate u with respect to x. Du dx equals to 1. Therefore, du equals to dx. We multiply both sides by dx. So du equals to dx. Then we have dv equals to sine nx. To get the value of v, we integrate both sides of this equation. dv, then integral of sine nx dx. So when you integrate dv, you get v equals to, when you integrate sine nx, you get negative cos nx over n. Negative cos nx over that. Therefore, once we have this, then we apply integration by parts. So we shall say that this equals to 1 all over 2 pi into uv minus v du, integration by parts. So this equals to 1 all over 2 pi into our u at this point is now x. Then our v is negative, so minus cos nx all over n. Then we are integrating from 0 to 2 pi, then minus from 0 to 2 pi. Our v now, which is minus cos nx all over n. Our du equals to dx. This one is dx, like that. Okay, so this equals to 1 all over 2 pi into this. This is the same as we have 1 all over n into minus x cos nx 2 pi 0. This and this will be positive, and we take out 1 all over n, so that we have plus 1 all over n into 0 2 pi cos nx, then dx, like that. So this equals to 1 all over 2 pi 1 all over n into minus x cos nx 2 pi, then plus. We now integrate what? We integrate cos nx. So when you integrate cos nx, we get this is 1 all over n into this will be sine nx all over n. Then you have 2, 0 to 2 pi, like that. So this equals to 1 all over 2 pi, 1 all over n into minus x cos nx, 2 pi, then plus, we take out 1 all over n and then multiply this will be 1 all over n squared into sine nx, like that. So this equals to 1 all over 2 pi into, so we now substitute this. So we have 1 all over n into, where there is x, we substitute with 2 pi. So we have minus 2 pi cos now 2 pi n, then minus 0. We are now substituting this 0 cos 0, like that. Then plus 1 all over n squared into now sine 2 pi n, then minus sine 0, minus sine 0. Therefore 0 times, so this would be, because we are taking 0 times cos 0, which is 1, so that is 0. So here we have this, and then we have we can now test this. We have sine 2 pi n. Of course, this sine 0 is 0, so we test this one. Sine, when n is 1, so we get sine 360. Sine 360 is 0. When n is 1, sine 360 is 0. So when n is 2, that is odd even number. So we get sine 720 to be 2 times 2. So we have 4 pi, which is 720. Sine, get sine 720 is also 0. So this one would be 0. We have this. Now we remain 1 over 2 pi into, now we can now even take out 1 over n, so that we have 1 over 2 pi n. Can even take out again, just a minute. We can take out negative 2 pi, and then with this n, so we have that all over 2 pi. This is n out, into now we have cos 2 pi n. That's what we have. And then these and this cancel, so we have negative 1 all over n into cos 2 pi n. Now we test when n is odd and when n is even. So when it is odd, we normally use 1. So we test with 1. This is 1. So we have cos 2 pi. Cos 2 pi is the same as cos 360. So we confirm cos 360. 360 is 1. So we can say that Pn equals to negative 1 all over n, n odd. When n is odd, we have that. Then when n is even, so n is 2. 2 times 2 for 4 pi is 720. So we test with 720 cos 720 is 1. So we are saying Pn equals to negative 1 all over n even. So we are saying that the series exists at both even and odd numbers. So we can now state the Fourier series. So the Fourier series of f of x equals to, I have, remember our A naught is pi. Therefore, f of x equals to pi over 2, then plus. Now we don't have that one will be 0 because an is 0. When you take 0 times cos nx, it will be 0. So we only have pn. And remember, pn is here. Both even numbers and odd numbers, we have the series. So we shall have plus, but because pn is minus, so we can have minus here. So minus, open the bracket. We have minus 1 all over n. So we take inside 1 over n. So when n is 1, so we have 1 over 1, and its sign. So it will be sin x. Then the next number, it will be 2, because the series exists both at even and odd numbers. So we have plus 1 all over 2, then sin, it will be now sin 2x. Then at 3, it will be 1 over 3. So we have plus 1 all over 3 sin 3x. Then at 4, it will be 1 over 4, which is this 1 over n. That's why we are getting 1 over 1, 1 over 2, 1 over 3. So the next one will be 1 over 4 plus 1 over 4 sin 4x plus. So it continues like that. So this is the Fourier series of the given function. Thank you for watching and listening. Bye bye.